Now, to give you a demo of that, what I'll do is I'll take the cable from this. This is the power cable that comes down. So you notice that that will fit inside the battery charge plug. Again, you want to make sure you have black to black. So I'm simply plugging it in like this. Okay, so black to black. I've got green, white, and red. So I'm actually providing either 3.7, 7.2, or about 12 volts here. Okay, I'm going to back up a little bit on that explanation because there may have been a question for that as to why I use this connector. Okay, in the Mariner configuration, we're going to have two batteries. Could be two of the 5000, could be two of the 2500, two of the 2300. It doesn't make any difference. But I recommend a dual battery setup because we have the additional room. One of these balanced charging plugs in will be used to plug in the circuit breaker for the LED lights that are built into the bottom of the Mariner. Now these lights then indicate not only orientation of the craft, but they indicate battery level. Okay, so this, either one of them are reserved for the plug in the nozzle. We generally would have one free, but a free plug can always be used for additional purposes. So that's the one that I use for my other power supply. And again, this plug does plug in, and again it plugs in to take the lights or the lights in the transmitter. So as a purist, yes, I am using some of my power from my motors and my ESCs to power my transmitter and the lights. We can turn it off if we want, we can turn it on. That's up to you. However, the batteries inside the nozzle are about like this. So if we wanted to, we could put a second, much smaller 3-cell battery inside. And I would recommend that because you still keep the center of gravity low. Or you could put another small 3-cell battery inside the top hat of the Mariner. Now this way, you'd still have your 3S cell, basically 12 volts, to power your lights and your video. You would not detract any power of the house batteries for your motor. Is it worth it? Well, we'll have to let that one up to you.
Excellent. Excellent.
In this case, we're going to demonstrate the FPV function. We have our GoPro camera. The GoPro camera has our audio and video output from that back circuit board I had mentioned, and in this case it's into a 600 milliwatt 5.8 transmitter going up through, in this case, a linear dipole antenna, but I would highly recommend a circular polarized antenna. So we're transmitting the signal back, and you can see the signal right there on the FPV monitor. We're inside a metal building, so we're getting a heck of a lot of reflection back from the walls with 600 milliwatts. So that's one of the reasons why we're getting so much feedback or jitter into this thing. Probably be much better in this case without antennas. Now we do have FPV goggles. Unfortunately our battery is a little bit low, but as we turn this on, the signal can actually be seen in the FPV goggles. Again, two ways to view this thing: by the FPV goggles or in some type of high-resolution monitor. But if you're going outside in sunlight, you'll definitely need some kind of very effective sunshade to go with that to give you a clear picture. Danny, any questions on this?
Question I have, Joe, is now the information that would normally be, or isn't there information that would be on the monitor itself, like your distance, your elevation, battery power? Doesn't that come up there on the monitor at all? No,
we're strictly sending the output of the GoPro into this.
Okay.
Now we can add another $40 box, and that $40 box would give us information from our flight control system, and it's called an OSD, an on-screen display.
Yeah.
So it overlaps or overlays the video from the GoPro and provides all that additional status information.
On-screen display, okay, that's what I was trying to think of.
Well, for the real drone videographer purists, the PhDs, the postdocs, come up with another system, and that is a 3-axis gimbal system that is located on the bottom of the Mariner. Now in this case we'd use a GoPro or equivalent camera. This thing could be powered by an internal 12 volt, actually a 9 volt battery. You can see I have a little area here for a clip with it. We put the GoPro on the mount outside the housing. In other words, if this hits the water as it is, it's totally history. It's gone. The saltwater especially would get it. So how can we preserve that? Well, one of the things that I've done is I've had some glass dome ports made, and these glass dome ports, precision ports, fit right under there exactly. So the glass dome ports actually have a foam sealed ring on the inside, and if you notice the orange foam sealed ring on the outside. So this then would allow us full 3-axis gimbal with your GoPro 4 or 5 or 6 or whatever you have, and give you a high degree of stability. If you accidentally landed in the water, or you were forced to, because of low battery, set it down in the water, your electronics would be preserved. Now, this is a glass dome, so if you are the kind of person who likes to run into buildings or smash it against the sides of steel-hulled Coast Guard boats, this is probably not for you. But if you treat it gently and respect what it can do in terms of filming, I think it's might be a pretty good asset. I don't necessarily think you're going to need a 3-axis gimbal. So what I'm working on now is a 2-axis gimbal, which would actually be exactly the same dome for this. So this 2-axis, 3-axis is one of the next up-and-coming additions or features. Now, it will have a full FPV setup with it, and that's in the future.
Excellent. Okay.